Hello the internet and welcome back to my channel. The Acer V58 is back on the bench. I worked on this board on one of my previous videos and I couldn't fix it, so at the end of the video I asked for your help. Now I've been absolutely submerged with messages, ideas, suggestions, just messages of general support, so thank you so much for that. I've come up with a list of things to try on the board and I have an idea of my own, so hopefully we can make this work today. Let me thank today's sponsor PCBWay, and now let's not waste any more time and let's start testing this board. I'm going to continue from where we left on the previous video, so if you haven't watched it, I recommend you pause this one and go and watch the previous one. But long story short, this board doesn't work, it doesn't do anything, and I did quite a lot of checks and I couldn't find anything, and in my opinion, the processor wasn't even starting, so I was stuck there. Now I've got tons of suggestions, from the simplest one, but still valid ideas, to the most complex ones, which requires a little bit of in-depth knowledge on how a CPU works when it powers up. Now I have a list here of things that I'd like to try. We're not going to go through everything because otherwise this video is going to take forever, but I just want to show you a few ideas, a few pointers that I've been sent. I've done a few tests on this one, and maybe we can do something together and see where we get at the end of the video. So let's talk about the simplest idea, but sometimes it doesn't take much for a board not to start. So the first advice I've been given is to try the board without the post analyzer. One of my viewers said one of their boards wouldn't work with the post analyzer. So I did try the board without the post analyzer, but I have no activity whatsoever. There is an integrated speaker on the board, so I don't need to plug anything, and that didn't beep or didn't do anything. The next step would be to try the post analyzer on the PCI bus rather than on the ISA. Number one, because apparently some boards do not produce the post codes on the ISA bus. Number two, because as we saw from the previous video, the CPU talks to the BIOS through the PCI bus. So if I have activity on the PCI bus but not on the ISA bus, it might mean that the south bridge, which is in between the PCI bus and the BIOS, might have a problem. That didn't work either. The board is still completely dead and I have no activity whatsoever on the PCI bus, not even the frame LED, which I believe is like a feedback on some kind of package being transferred on the bus. Another one of my viewers mentioned the battery. Some boards don't like having a completely flat battery, but unfortunately that battery is still reading 3 volts, so it's not the battery. Another suggestion I got is the fan, and the idea is maybe the board is not starting because the fan is missing, and somehow the board is able to detect that the fan is not there, and to avoid overheating the CPU is just not starting. I kind of feel this might not be the case with the Socket 7, but it was worth checking. I plugged the fan and no, the board is still not working, and also the fan is not spinning, which is something I'll get to in a moment. One thing I forgot to check is to check the socket, because it might be damaged, there might be some corrosion somewhere, and it might not make contact with the CPU pin. Now, this CPU actually can be accessed from the top. As you can see, got all the pins visible here, so I could actually check with a multimeter for continuity from top to bottom. For now, what I've done, I checked with my microscope, and the socket seems to be in very good shape, so I don't think that's a problem, but I could also check that there is continuity between the top and the bottom. That's actually a great idea. Another pointer was looking for damages or scratches, and yes, sometimes all these things, they don't end up in my videos for, length constraints, but I did check for damages, I did check for scratches, I couldn't see anything. Now that doesn't mean that there isn't a hidden damage or something. I have seen in the past SMD components which look totally fine at bare eye, but when you look under the microscope at very high magnification, they're like split in half. So that's still an option, but I haven't noticed anything, and I inspected many times. Another basic check is for shorted components. Now I have checked with the thermal camera, I haven't seen anything. I've checked with my fingers, I'm not feeling anything. The CPU is getting warm, so something is happening, but there's nothing getting scorching hot. So that shouldn't be a problem. I've also been recommended to press on the BGA packages here and see if the behavior changes, and yes, I've tried that before and unfortunately didn't work. I used this very method to diagnose my Amtron 9600. It was completely dead, and when pressing on the North Bridge while powering up, it would post, I think, completely, and eventually I reflowed the north bridge and it started working again. I pressed both the north bridge, the south bridge, different positions, several times, so many times. I couldn't get a glimpse of activity out of my post analyzer card. So yes, I could reflow these chips. That's another suggestions I've got from many of you. I'd like to leave the reflow option to the end. Let's say my BGA reflowing, reballing success is not too high at the moment. So I'd hate to reflow the ICs, popcorn them, and that's it. Then it's end of the line. But I did try warming up the North Bridge and the South Bridge with my hot air station, obviously not too high temperatures, hoping for some kind of change, pressing while warming up, and nothing ever happened. But let's get to the more technical suggestion. This came from a number of users, including 𝐃𝐞𝐚𝐝. Thank you very much for your help. And I think it's down to my poor knowledge of how a CPU is actually working. So in my previous video, I was looking for pulses on the address line and data lines of the CPU, and I said, well, I don't see any pulses, not even one, so that means the CPU is not even starting. Now, on a healthy system, yes, the CPU would start pulsing, and that means there is communication between the various components on the board, but in this case, it might be a different story. It turns out that when a CPU starts, the first thing the CPU does as soon as the reset line disengages is to output a reset vector. The reset vector is an address that gets translated through the North Bridge, South Bridge and XD bus to the BIOS. The BIOS usually has a jump instruction on that address, and then, you start back and forth and there is execution of code. But the first thing the CPU does is calling for the reset vector. Now, the reset vector on a 32-bit CPU is FFFFFF0, 7 Fs and 1 0. And if I'm using just Windows calculator on the programmer mode to check in binary what FFFFF0 is, it means that address lines from 31 to 4 are gonna be 1 or high, and from 3 to 0 are gonna be low or 0. So if I went to scope all those address lines, the 32 address lines, while the CPU is outputting the reset vector, I would find them more or less all high, but address lines 0, 1, 2 and 3. And I think that is what's happening with this board. If you remember from my previous video, I was probing all the address lines and most of them were high. And it makes sense, when the CPU starts, most of the address lines are supposed to be high, and that gets translated to the BIOS, and the BIOS should respond with something, which is not happening. But the CPU apparently was doing exactly what was supposed to be doing. So this changes things a bit, because it looks like the CPU is actually doing something. It's not completely dead. It's actually something is not coming back to the CPU. I would need to check this one, but it's kind of consistent with what I've been observing on this board. So the next step to check is probably the North Bridge, or the XD bus, or the South Bridge, because it looks like there is information coming out of the CPU, and we would need to find out what happens to that information. Is it reaching the BIOS? Why is the BIOS not responding? There's a number of steps to be doing. So that's a great information. Thank you very much, everybody who mentioned this, because this is clarifying so much better. It's nice to know how this thing works, and I appreciate it's pretty complicated to trace how a CPU is starting and what happens over the first few seconds, but this is a great start. It gives me quite a lot of knowledge that I didn't have before. Now, before we get into this, let's call it rabbit hole of tracing what the CPU is doing, where is the signal going, who's receiving it, who's not receiving it, I'd like to show you something else which I think might be relevant. So let's go back to the fact that apparently there's no 12 volts coming out of the fan header. Now, on a board of this age, I wouldn't expect the fan to be controlled by anything on the board. It would just be hardwired to the 12 volts directly from the power supply. So the first thing I did, I powered up the board, and yes, I confirmed that there's absolutely no power coming out of this header here. So I started tracing the pins, and the left-hand side is the ground. The right-hand side is going under here somewhere. It's ending up in this white socket here, which is the hardware monitor socket. There's no information whatsoever on the manual, just that it's a hardware monitor socket. There is a jumper inside. I do have a feeling that this is something to do with our problem, But again, for now, let's ignore this one. But what I've noticed is that this pin here on the right-hand side is actually connected to the fan here. And from here, I think it goes around here. There is a capacitor and then it goes to ground. So I have no idea where it also goes. It might go inside the other layers of the board. Is the fan getting power from this very connector, from an external module I'm expecting? I have no idea. But anyways, that's really not relevant, because while I was doing this test, I remember, then I noticed, and I remember this thing that says power bottom. Obviously it's a typo, it says power button, and it points at this CN18, which is a header. Now, this header is mentioned in the manual. It says power button, and if I'm checking it with my multimeter, I can see that the outer pins are ground, so I'm connected to ground now. So these are connected together and are ground, and the middle pin is not outputting anything and is not directly connected to 5 volts or anything. So, I thought I can try and short these 2 pins and see what happens. I think I tried that before, but I wanted to try that again. Let's install 𝐃𝐞𝐚𝐝's favorite heatsink. There you go, this will do. Now, if I power up the board, and again, it's not doing anything, and I check the middle pin, I'm reading 5 volts, but again, this is probably coming from some logic of some sort, somewhere around the board. Again, it's not coming straight from the power supply. So what I've done, I've got this little push button here. It's a push button connected to a couple of terminals, and I just wire them into my power bottom. I've got the post analyzer back in. I can power up the power supply now. There's no activity here, and if I push my start here, my power bottom, nothing really happens. So I thought, okay, no, this is not working, whatever. And then I thought, what if this power on button is supposed to be a latched button and not just a push button like this? So what I did, I powered on the board and I hold my finger on the power button here. So power on again, there's nothing happening. And if I hold the switch here, well, something's happened. I got something out of the speaker. The reset line is now engaged and it's not disengaging. And I thought, okay, that's not really telling me much. So I powered off the board again, and then I powered it back on, and it went exactly in the same state. However, if I power off the board and pretty quickly power it back up and push the button once, let's see what happens. Power off, power back up, and button. I've got a code on the post analyzer card. And I thought, okay, that's weird. What's happening here? And then I thought, well, 01 is not much, even though, again, it should mean a few things. But then I realized that on this BIOS chip, I have Dexter's test BIOS. And if you remember from the previous video, this test BIOS is doing exactly that only. It's only displaying 01 on the post analyzer card, and it stops. So let me turn it off because my heatsink is small. Does that mean that the board is running? And then it's when I stopped doing it and I thought, okay, I need to turn on the camera and show everybody. So this is where I got this morning. The next thing I need to do is to reflash the BIOS with the BIOS I found with the board and see if by any chance this actually works. Right, the existing BIOS, the one I found with the board, is back on the IC. Now let's try and replicate the previous startup sequence, which is very weird. So first of all, I need to apply power. Then I need to, let's say, I don't know, reset the board through this power switch. There you go. Then I will have to power off, on again almost immediately, and then power on again. Will it work? Let's have a look. Power off, power on. Seriously? I don't think it's... I don't know. It's definitely working. It's executing code. It's not beeping. It's probably... I don't know. I need the video card. But this is... I knew it was just something with the board, with the jumpers or anything. Oh my gosh. Let's turn it off. This thing is working. Okay, I've got my basic S3 2D video card in it. Let's trigger this sequence and let's see whether this thing is actually outputting something. I'd be very surprised. Power on. Trigger the reset. There you go. Power off. Power on. Go. Look at that. Oh my gosh. I cannot believe this. It's working. It's freaking working. It is working. It's working. RAM parity error. Okay, I don't care. I have no word. It is working. It is working. So this thing works, and apparently I don't need to do that weird start sequence. All I need to do is to press the power button immediately after power has been applied. This board is definitely working with some sort of external power sequencer or whatever. My only guess, considering there is a power button and a suspend socket here, but we don't have an ATX power supply, is that this is kind of mimicking the ATX power supply before ATX was even available. So all I need to do here is just to turn on and press this button immediately. So on and this, and that's it, and it works. Now, I've noticed that my compact flash doesn't work from the primary controller, so I'm not sure whether that might have a problem, but it definitely works from the secondary. Look at that, it's working. Gosh. So the board is working. I can't believe it. I had this guts feeling. I can tell you, I didn't know about this, but I had this guts feeling considering we had this hardware monitor socket and all these power strange things. You know, the board came with a jumper in a position where it wouldn't even come out of reset. I knew it was something like that. Well, I didn't know that, but I had this guts feeling that it was something like that. If you know anything about this board, you know, does it belong to an Acer system and it comes with a little something? Now I have a device here which I'll show you at some point. It's an ATX based motherboard, but the manufacturer wanted to have an on-off button at the front panel, so not a push button that you have to hold it to switch off or something. They wanted someone to be able to switch it off, and they developed a little circuit board which works with the power on line of the power supply and the rocker switch outside of the case to make it work. So I'm assuming this has something like that. Acer maybe developed this thing to for whatever reason. But the board is working. That's the basic thing. To be honest, I don't care too much about how this board is supposed to work, because I really haven't got the case or the power supply that would work with this board. The board is working. It's always worked. Well, the board is working totally fine. Regarding the primary IDE port, which wasn't working before, well, I'm now using a mechanical hard drive here, and it's working totally fine. So I'm not sure why that port doesn't like my compact flash here, but it's working, so I don't know. To be honest, I have no idea. I could see in the BIOS the compact flash was being detected. I could see a hard drive of 1 GB, which is the size of my compact flash, but for whatever reason, it was not booting up. I don't know, but again, it's working with a physical drive, so I think it's okay. When it comes to the BIOS, I did flash the version that I found online when I was troubleshooting the board for the first time, and it's exactly the same version. It's version 3.0, same date code, so there is no update for this board. This is the latest version, or at least the only version that I could find. And for that memory parity error, it was just a matter of going into the BIOS and disabling the ECC the board was expecting from the RAM, which is kind of weird that the default BIOS is expecting ECC RAM. So I'm wondering where this board is coming from. Where was it being used, in what kind of system? That actually might explain the complex power system of this board. If this was not a desktop board, it was mainly using maybe in servers or something like that, then the server will have that kind of weird hardware monitor, and which is also powering the fan apparently, because the fan is still not getting power from the header. So I'm assuming that because I noticed that the fan is connected through the hardware monitor header, it's probably being driven by an external module, which is probably looking after the whole health and temperatures of the system. Little spoiler alert, this project would have been perfect for PCBWay. I ended up not using PCBWay just because designing PCBs is still not my thing. I'm a bit slow in doing that, and I didn't want to delay this project anymore, but that would have been perfect. You'll see that in a sec. But the good news is that you don't need to be an expert in designing PCBs to use PCBWay services. There's plenty of projects online, and that's what I've been doing all this time, just using existing projects, uploading the Gerber file on PCBWay.com and just get the PCBs at home, which I can populate myself. If you want to design your own PCBs, plenty of free tools online to do it. This is actually the very first PCBs I've designed. You've seen that in a future video. But regardless of what your needs are, PCBWay has a solution for you, including 3D printing and metal sheet fabrication. Take a look at PCBWay.com, the link is also down below in the description. Let me thank PCBWay for sponsoring this video. Their help makes these videos possible. Now let's go back to the V58. So I thought about ending the video here because in the end the board works, and I thought I'm not interested in investigating even further on how the board is powering up. But then I thought, what if there's an easy way to return this board to the owner with some kind of simple device, simple circuitry, which can actually power on the board and transform this board into a regular AT board where you just apply power and the board starts up. Now, one thing I've discovered just this morning is that I don't actually need to pulse the power on pins just after the motherboard has been energized. I can actually hold the button here, so I can short those two pins on the motherboard, apply power, and then release this button, so remove the short, within like 4 seconds. After 4 seconds, the boards enter like a permanent reset state. I have no idea why it does that, but as long as that happens, the board starts straight away. So let me show you. If I short my power on pins and I power on the board and I release this within a number of seconds, it works totally fine. So one of my viewers came to help, 𝐃𝐞𝐚𝐝78. Now 𝐃𝐞𝐚𝐝78 came to help with the power supply repair a few videos ago, so thanks again for your continued help. 𝐃𝐞𝐚𝐝 knows electronics, I don't, I tinker with electronics, and he's come up with this little design, which is supposed to be a simple way to just delay the power on pins when 5 volts comes to life. So when power is applied, this little circuitry senses that 5 volts is coming up, and the transistor is releasing the power on pins with a small delay. So that's definitely something that we can try. However, since I realized that I don't actually need to pulse those pins, but I just need to make sure that they are shorted when the motherboard is powered on and then they're released within 4 seconds, I thought, what about using a relay? So here I have a 12 volts relay. I haven't got 5 volts one, so this will do for a time being. And this is going to be more or less directly connected to the 12 volts line of the power supply. So when I apply power, the relay is energized, and I'm going to wire the power on pins of the motherboard on the normally closed pins of the relay itself. That means that those pins are going to be shorted when the motherboard is unpowered, and when I power on the motherboard, the relay is getting 12 volts, so the contact on the motherboard will get open again. Now, obviously this is happening simultaneously with 12 volts, even though this is a mechanical device, so I guess there will be some milliseconds of delay, so that might be enough. If not, I can use a capacitor and a resistance to just try and slow down the activation of the coil. I have a feeling that this is going to be totally fine, and if that doesn't work, we can go with plan B, which is the more complex circuit that 𝐃𝐞𝐚𝐝 made for me. So let me get a piece of prototyping board and I'll patch something together and we'll see if it works. Okay, so I went with the breadboard. Right now it's just a relay wired to 12 volts. There's no capacitors, no nothing. So without power, these two wires are shorted. With power, they're not shorted. Let me show you. This is without power. This is with power, and without power. So, just out of curiosity, let's see if by any chance this just works. Okay, power up, 3, 2, 1, go. So no, it doesn't work. We need some delay. Let me try and add the capacitor and the resistor. I've added the capacitor across the coil and the resistor in series with the coil, so in theory the capacitor should first charge up before the coil is energized. Let's see whether it makes any difference. It's a random value resistance of 10 ohms and a random value capacitor of 1000 microfarad. No idea. Let's give it a go. 3, 2, 1, go. It's still too fast. Let me tinker with those components and see if I can improve it. Now, to increase the delay, I can either increase the capacitance or the resistance. Now, just out of curiosity, I got a 470 ohm resistor, but that will obviously drop the voltage at the relay coil to the point where the coil might not work anymore. But I just want to give it a go and see what happens. 3, 2, 1, go. Well, it works. But it doesn't work as the relay is pulsing, so that's telling me that the voltage is dropping below the minimum that the coil can actually work, but the pulse actually makes the motherboard posting. So I'm not sure this qualifies as a solution, but you know, it could work. The thing is, I think the voltage is too low, it gets probably going to be unreliable over time. And yes, the voltage is only 7 volts, 0.4, the relay is 12 volts, so it works, but it doesn't really. So that's not really a solution. Let me take a different approach. So I'm back to the 10 ohms resistor, that should be okay for the voltage, and I've got the biggest capacitor, I got 10,000 microfarads. Obviously, this is a bit bulky, but I'm curious whether this is gonna work, because there's no point in testing this method if with a 10 ohm resistor I can't get enough capacitance to delay it enough so that the board is posting. So let's try with this one. Power up in 3, 2, 1, go. Well, it's working. Now, obviously, this massive capacitor can't be a solution, so let me try with something in between. We tried with 1000, it didn't work. Let's try with, I don't know, 2000, let's see what happens. 2200 microfarad capacitor is in, let's try this. 3, 2, 1, go. And it still doesn't work, so I guess I can try and find with a slightly bigger resistor and see if I can find a good balance, but I don't think this method is going to work. So I'd like to try 𝐃𝐞𝐚𝐝 method, which is a bit more complex. So I'll put together the circuit on the breadboard and we'll try that one. Here is the revised version. It's a bit more sophisticated. There's a small transistor here driving the relay. Now, I haven't tried this myself because I'm totally expecting the magic smoke coming out of this breadboard. So we'll test it together and see if it works and if there's any smoke coming out of it. Ready to go? In 3, 2, 1, go. That should have worked, as I heard a click like after half a second. Let me remove from the board this 10 kilo ohm resistor. I think it acts as a current protection for the power on pins. After all, it's a relay, so nothing should really happen to the motherboard. Last famous words. Let's try again. It works amazing. So thank you very much, 𝐃𝐞𝐚𝐝. This is so cool. So what I think I'm going to do, I'm going to order like a 5 volts relay. And so we go back to the original project with the original values. And I'll put everything together onto a small prototyping board, a little thing, and wire everything in a way that hopefully the owner of the board can just plug the Molex onto this thing and just wire the power on pins of the motherboard. And then the motherboards can be used like a regular motherboard, which you can, power, and it actually starts. A few days have passed and I've got some very small 5 volts relays for signals and some headers, 90 degrees female headers, and I've cannibalized the floppy connector, the power floppy connector from my IDE to SD card adapter, and I've come up with this. This is the final and nice version of what we did on the breadboard, and it has an extra feature. The feature is that it has the cute part on this side here and the ugly part on the back. PCBs are not my thing, so you will excuse me for that. And the nice thing of this, if it works, I have tested it with 5 volts, but not on the motherboard. I know it clicks and it doesn't catch fire, so that's a good thing. The idea is that this header here is going directly on the motherboard. It plugs directly on the power on connector and it works with the floppy connector here. We just need to test it and make sure that it works, because the previous version was the 12 volts and I had changed some of the resistors values, so I'm not sure whether this is going to be timed correctly. The device is plugged in. Well, let's see if it works. Here goes nothing. 3, 2, 1, go. Oh, doesn't work. Guess the timing is incorrect. So the delay was not enough to increase it. I replaced the 47 microfarad capacitor with a 220 microfarad capacitor, and that should help. So let's try and see if it works now. 3, 2, 1, go. Yes, it is working. Now this relay is very quiet, but let me see if I can pick up the noise through the microphone. If I'm hearing it right, there's about 1 second delay, which is perfect. I needed probably like 200, 300 milliseconds, but 1 second is totally fine. And this is probably making it even more reliable. It's never going to miss it if it's about 1 second. So great, we got the final solution. It looks okay. It's a bit like do it yourself, but I guess it works. And that will make this board fully working with a standard regular AT power supply. Well, I'm pretty happy with this video. We didn't fix the board. The board was actually working. It was just a matter of this weird power on sequence, but I'm so happy that I managed to put that together so I can actually return this board to its owner in a, let's say, in a working state. Again, it was working before, but at least now they can use it with the regular power supply and finally enjoy this V58. A big thank you to 𝐃𝐞𝐚𝐝 who helped me with that design. Actually, it's his design. I just put it together. So thank you very much for your help on that. You're amazing, and it's so nice to have this board finally completed. I hope you enjoyed the video. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel if you like this kind of things. I'm now on Patreon as well, so if you feel like supporting this channel, you find the Patreon link down below in the description. But if you don't want to join Patreon, you can just buy me a coffee, and the link is also down below in the description. Let me thank my Patreons. You're all amazing. Your names are scrolling at the side of the screen here. Thank you so much for your support. I was not expecting that, to be honest, so I'm completely overwhelmed by your support. You're amazing, and I hope you enjoyed this video as well. Well, that's it for today. Thank you for watching. Have a great day, and we'll see you here for my next videos. Thank you very much, and goodbye. Bye-bye.